Today we're going to look at how we can create GraphQL microservices using Nest.js and Apollo Federation. We're going to go ahead and create two GraphQL microservices, one for users and posts. Then we're going to go ahead and create a common Apollo Federation gateway that's going to stitch together each of these GraphQL microservices into one schema and expose them over one URL. We're going to go ahead and be able to create a new user, create posts for that user, and then look up the user as well as all the posts for that user in the same exact query, as well as looking up the posts and the user for a given post. This is going to appear to be a seamless schema, even though under the hood we are going to be running 3 different GraphQL servers, and Apollo Federation is going to take care of stitching them all together. Let's go ahead and see how we can accomplish this with Nestjs GraphQL up next. Okay, so we're ready to start creating our Nestjs GraphQL microservices. As always, I'll include a link to the GitHub repository in the description, which will contain the completed project. I'm going to use the Nest CLI to go ahead and generate a new application. And I'm going to go ahead and call this first application Gateway, because this starting application is going to be the gateway for our GraphQL microservices. We will see this in action in a little bit. Let's go ahead and choose pnpm as our package manager and let the installation complete. So I'll go ahead and cd into the newly created gateway folder and then open up this project in a code editor. So we can see we've created the default Nest application, which is an HTTP server listening on port 3000 with a default GET route. So this starting application, as I said, is going to be the gateway for our Nestjs GraphQL microservices, which means it's going to be the starting point that receives all of the HTTP requests and then stitches together the response through the various GraphQL microservices that we specify. Let's go ahead and now convert this project into a monorepo where we can continue to add our actual GraphQL microservices. So back in our terminal, I'll use the Nest CLI again to generate a new app here. I'll go ahead and call this first microservice users app, which will go ahead and convert our existing application to a monorepo setup where we now have an apps folder where we can see our starting application in the gateway folder, as well as this newly created users application. Finally, let's go ahead and generate one more app, and this app will be the posts application. So now we should have 3 applications, our gateway, and the 2 GraphQL microservices here. Now let's go ahead and generate some boilerplate for each of these services so we can see how we can actually stitch together these schemas and produce one GraphQL server. Back in the terminal here, I'll go ahead and generate a resource here by calling Nestjs resource. This is then going to ask us which project we want to generate the resource to. We'll start off with the users application here, and then it's going to ask us the name for our resource. In this case, we will call it users, and then we can select the GraphQL code first transport layer, which is what we're using. We'll go ahead and select yes to generate CRUD entry points. And now we have generated some boilerplate users code in the users directory. So let's go ahead and select all of this newly created resources in the users directory and move it up one into the source directory and go ahead and replace the existing users module and service. Then we can go ahead and delete this duplicate users folder. And now we are left with a users resolver service, and we can go ahead and delete the controller as well as the test file for it here. So now we have a newly created users resolver, which has all of the CRUD entry points for a Nestjs GraphQL server automatically created. We have queries to find all, find one, and we have mutations to create as well as update and remove. For our use case, we're not going to include update or remove, so we can go ahead and delete these two. Go ahead and delete this import here. Then in the DTO folder, we can go ahead and delete the update user input as we won't need it. Now let's go ahead and check out the user service, which was newly created. You can see we have corresponding CRUD methods for all of the users resolver routes. So let's go ahead and delete the update and remove as well. And now if we go back to the users resolver, of course, we can see it complaining because we don't have the Nestjs GraphQL dependency yet. So let's go ahead and add all the dependencies we're going to need. Back at the root of the project, I'm going to go ahead and pnpm install the following dependencies which we'll use. Firstly will be Apollo/gateway. We're going to use Apollo/subgraph, Nestjs/Apollo, Nestjs/GraphQL, and lastly GraphQL itself here. So now that we've installed the needed dependencies, we no longer have an error being thrown. Let's go ahead and set up the user's module to hook into Apollo Federation. We added imports array here where we can call GraphQL module from Nestjs/GraphQL and call for root here. Then we'll provide an options type here of Apollo Federation driver config. I'm going to go ahead and pass in an options object here. We'll go ahead and add an import here up top for the driver config. So go ahead and add this and import this from Nestjs/Apollo. So inside of this options object here, we'll go ahead and specify the driver we're going to use. In this case, it's the Apollo Federation driver from Nestjs Apollo. Importantly, we also need to specify the auto schema file here, where we'll go ahead and specify the federation type or version. In this case, we're using Apollo Federation 2. Let's go ahead and start up our user service in our terminal by calling pnpm start dev users. And now in our browser, if we go to localhost 3000/GraphQL, we can see a GraphQL playground server running where we can see the docs for our current queries available, including fetching all users here. And you can see by default, we only have one example field defined on the user. And we also have the query to get all users and to create a new user with this one field. And this corresponds, of course, to the entities we have defined for the user here, where we have this one example field. So instead of this one example field here, let's go ahead and refactor this user to take in some different properties. Firstly, we'll keep this field and define an ID on the user. So this ID comes from Nestjs GraphQL, and we'll go ahead and call this ID of type string. We'll also go ahead and add a new field for an email for the user. And finally, we'll have one more field for the password for this given user of type string. Next, let's go into our DTO folder, and for our create user input, we're going to go ahead and refactor this and actually just include all of the properties on the user here and allow these to be passed in as part of our DTO or our mutation for the create user. We can get rid of the ID field here and just specify this as a string. And let's change the find one for the user to now, instead of taking in an integer, we'll go ahead and say this ID is a string. And now in the user service, we'll go ahead and change this as well to take in a string. Now let's go ahead and refactor our user service to actually have some CRUD functionality on an in-memory list of users. First, I'll go ahead and define a new users variable here, which is an array of user entities that we've just defined. So now in our create method here, let's go ahead and push the users array with a new create user input, and then we can return it back to the caller here of that newly created user. So you can imagine this is where our database persistence would take place. Next, for the find all, we can simply return this .users, and for find one, we will return this .users.find, where we look for each user and compare the ID on it to the passed in ID here. So now back in our GraphQL server in localhost 3000/GraphQL, you can see our newly updated user here. So let's go ahead and try this out by running a mutation called create user. We know this takes create user input of type ID here. We'll use 123, an email of type test@example.com, and our password here can be test. So from this newly created user, let's pull back the ID, email, and password. So you can see our user has been created and we get the response back now. Let's go ahead and query this particular newly created user by calling query user and passing in our ID of 123. We'll pull back the ID, email, and password. Now we can see we're pulling back the user we just created. And finally, let's go ahead and get all users here. So we'll pull back all users and pull back the ID, email, and password. Now we can see an array of all the users. Now that we have a basic CRUD user service set up over GraphQL, let's go ahead and do the same for our post service before we go ahead and compose them together using our gateway. Back in the terminal, stop our service here. I'll use the Nest CLI to generate a new resource here that we will go ahead and generate to the post project, and we'll call this post. Just like we did before, we'll go ahead and use the GraphQL code first and select yes to get the CRUD entry points. Now we can see in the post service this newly created posts resource. Let's go ahead and copy over all of these resources directly into the source folder, move them in, and replace the existing ones. We'll go ahead and delete the posts folder now, and go ahead and delete the posts controller as well as the test file for it. Back in our post resolver, let's go ahead and delete the remove post and update post methods here, and delete the update post input, and we'll go ahead and delete that file in our DTO directory as well. Next, in our post service, let's go ahead and remove these CRUD methods and the import as well. Then we'll go into our post module here and add the same imports we did for our users module. So let's go ahead and just copy over this import from the users module where we set up this GraphQL microservice. We'll need to import the GraphQL module, the Apollo Federation driver config, as well as the Apollo Federation driver itself. Finally, in our main.ts, let's go ahead and actually listen on port 3001 here so that we don't clash with our running user service. Now let's go ahead and npm start dev on the post service. Now we should be able to go to localhost 3001/GraphQL and get our posts GraphQL microservice. We can see the docs for it here where we have the same queries we had in the user service with our example post type here with the example field. Let's go ahead and refactor this just like we did for the user service. So I'll start off by going into the post.entity, and let's remove this example field now. I'll go ahead and firstly add the ID field just like we did for the user, where we specify this ID from Nestjs GraphQL of type string. And then I'll add a field for the body of the post here of type string, and then we'll have another field for the author ID, which is the user that actually created this post, and linking the two together. This will be of type string. So let's go ahead and copy these properties now, and in our DTO folder, we'll go ahead and replace the existing field with these three properties that the users can supply, and we'll get rid of the ID decorator here. And let's go ahead and remove the default integer value type of the ID being passed in, as this will be a string. So we'll go ahead and change this to a string. And now in the post service, we'll also change the ID of type string. And let's go ahead and refactor this service now, where we have an in-memory list of posts. So we'll have a private read-only posts variable here that gets set to an empty array, and we'll import the post from our entities folder. So now in create, we can call this .post.push, create post input, and return the create post input. Find all is going to return this .posts. And find one here is going to call this .posts.find, where we have a post and compare it to the post ID and the ID that is being passed in to this method. So now back in the browser, we can go ahead and see our newly updated post here with the newly updated properties. Let's go ahead and try creating a new post with a mutation here of type create post that takes in our create post input. Firstly, we have the author ID. We call 123. We'll have the ID of the actual post, which we'll call 234, and then body, which is going to be the text of the post here. So let's pull back some properties, the ID, author ID, and the body of this post. Now, if we go ahead and create it, we can see our response back. Let's go ahead and query for this newly created post by calling query post, passing in the ID of 234, and getting back these properties on it. We can see we get the post back now, and finally we can check to see that we get every post in the system and get the ID, author ID, as well as the body here. We can execute this and see our array of posts being returned. So currently, to get access to posts and users, these are on two different servers entirely, or two different ports, and there's no way to share data between the services. For example, to query the user directly on the post, or to query the post directly on the user here. We can't do that currently in one nice, easy graph. Instead, we have to have these two separate graphs. Let's go ahead and fix that now by using Apollo Federation and utilizing our gateway. In the gateway folder, let's go ahead and listen on port 3002 now, so that we are listening on an independent port. And in our app.module, let's go ahead and set up our federation. We're going to call GraphQL module for root here, and for our type, we're going to supply Apollo gateway driver config here from Nestjs/Apollo. So now we provide an options object where we specify the driver, In this case, it's the Apollo gateway driver. We can supply a server object where we're going to go ahead and specify CORS across origin resource sharing to true, so we don't have any problems communicating between our services. And now the important bit here is the gateway object, where we provide a supergraph SDL property, which is essentially how the gateway will stitch together the all-encompassing graph on our different microservices. To do this, we can utilize a utility function exposed by Apollo Gateway called introspect and compose. So let's go ahead and import this up top. We'll go ahead and import introspect and compose here from /Apollo/gateway. Now we can provide an options object to this utility function where we have the subgraphs array, and these are going to be the list of subgraphs or different GraphQL microservices that are running and how to access them. So we'll go ahead and supply this first subgraph here, which is the user service or the users graph. We'll go ahead and supply the name of users and the URL of where to find this service or subgraph. In this case, we know that's at localhost 3000/GraphQL, which is where our user service is listening on. In our main.ts file here, we supplied port 3000. Next, we'll go ahead and supply the post service here as the second graph, and the URL to access this will be at http localhost 3001/GraphQL. So we're still running the post service, and in a separate terminal, I'll go ahead and cd into the same folder, and now I'm going to start up my users microservice. So now our user service is started. In a third terminal, finally, go ahead and npm start dev and leave this blank so that our default app, which is the gateway, will start up. Now back in our browser, let's go ahead and navigate to the gateway URL of localhost 3002/GraphQL. So now we're at localhost 3002, which is our gateway server. And if we go ahead and look at the schema for the server, we see all of the schemas from our microservices, including the post here and the user. So you can see both of these graphs have been composed together into this one graph, which is our gateway server. We can see the docs for all of our available queries for posts and users, as well as how to create a post and a user. Okay, so I've gone ahead and recreated all of our mutations and queries on our gateway GraphQL server now. So now we can go ahead and create a new user here and go ahead and create a post for that user. And then we can go ahead and query all the users in the system as well as all the posts in the system. So this is great now that we only need one service running to compose all of our different subgraphs or microservices into one. However, now I want the functionality to be able to obtain the user for a given post and a post for a given user all in the same query. We can accomplish this very easily with Nest.js Apollo Federation. Let's go ahead and see how next. Okay, firstly, let's go ahead and in our apps directory and in our user service, let's go ahead and change the current user entity. We're going to go ahead and add a new directive to this object type. So use the directive decorator from Nestjs GraphQL, and we're going to use the @key directive here, where we'll go ahead and specify the key fields. In this case, it will just be the ID itself. So this tells the Apollo Federation how to identify a given user entity by its ID. Next, let's go into the user's resolver and add a new resolve reference decorator here. And we import this from Nestjs GraphQL as well. We're going to go ahead and define a new function here called resolve reference. And this route is going to get executed by the gateway when we need to translate an author ID on a post and find the user for that given ID. So it's going to get passed in this reference property here where we have a type name of type string, but importantly the ID here of type string, which is going to correspond to the user ID here. So we're going to go ahead and specify that we're going to return a user, and then we can call this userService.findOne here. Now we can go ahead and supply the reference.id to get the user ID on this given post. Okay, so next let's go into our post service, and under the entities directory, we're actually going to go ahead and create another user.entity here. And this user entity is the one that's only going to be known to the post service. So this post service user is still going to be another object type here, And importantly, it's going to have a directive, the same that we had earlier. We'll go ahead and specify the key field here. In this case, the key field will be ID, just like we did earlier. Then we'll go export a class called user, and then we can supply a field here of type ID. So we have the ID type here, and this is going to be the ID of type string on the user itself in the post service. And then now we're going to have another field here where we can return all of the posts for a given user. So we'll go ahead and import post here from our post entity. And this post field is going to be an array of posts for the given user. Now finally, let's go into the post entity itself and add a new field here where we can go ahead and return the user for this given post. And importantly, note that we're importing the user that we defined just now in the post service. So this property here will be of type user. Now in the post resolver, we'll go ahead and define another resolve field property here where we go ahead and actually resolve a given user based off of the post. Make sure we're importing our user entity here, and then we're going to have a user function, and we can access the parent type here by using the parent decorator. In this case, we know this will be of type post, and we are returning the information needed to look up this user on a post. So if you remember correctly in the users resolver, this was the object here for the reference, which included the type name and the ID of the user. We'll go ahead and return an object here that specifies a type name of user. And importantly, we need to supply the post.authorID here, which specifies which user we need to look up in the user service. Now finally, to actually be able to look up the user on a given post, we need to go and implement this in a new users resolver in the post service. So let's go ahead and create a new users.resolver.ts. So we'll go ahead and add a resolver decorator here from Nestjs GraphQL, where we go ahead and return the user that we defined in the post service. We'll go ahead and export a class called users resolver now, and we will inject the post service here. Now we'll go ahead and specify, just like we did in the post resolver, we'll specify the resolve field function where we specify all of the posts for a given user. So I'll go ahead and call this posts, and again we can get access to the parent type here, where we know the parent type is going to be the user, and we will return an array of posts for that user. So we'll go ahead and return this .post service for author and pass in the user.id here, and then we'll go directly in the post service and implement this function. So to do this, we'll create a new function called forAuthor that takes in the author ID here of type string, and then we're simply just going to return this .posts.filter and filter the given post on the post.authorID is equal to the author ID passed in, so that we only return posts by this author ID. Finally, make sure we add our new users resolver to our posts.module here. Lastly, make sure we stop and restart our gateway server to pick up our latest changes from our microservices. After doing that, we can go back to our gateway server, and if we look at our schemas now, we can see for our post type, we can get the user for a given post, and for the user type, we can get all the posts on that user. And the gateway is actually responsible for making the underlying network calls to our GraphQL microservices and stitching the final result together. And so now we can accomplish these queries very easily and get all the results we want in one query. So let's go ahead and test this out. We create a new user here with ID 123, and then I'll go ahead and create a new post here with ID 234 for that user, and have a text of body text. We'll go ahead and create another post for that same user and say body text 2. And now if we go to query our users, we can actually pull back the posts for that user. Let's pull back the ID, author ID, and body. Now if we pull back the user, we can also get all the posts for that user in a single query thanks to our Apollo Federation gateway. We can also do the same to query the post directly. We can now get the user on this post and pull back the ID, email, and password. Let's go and execute this, and you can see we get all the posts and also the user on each post. Okay, so I want to show you how we can apply authentication and add context data to our gateway so that we don't need to apply authentication to each of our GraphQL services and expose them publicly. We only expose the gateway and implement authentication on that service alone. So let's see how we can do that. In the app.module, we'll go ahead and include a new context property here where we'll have an authentication mechanism. Let's go ahead and implement this by creating a new auth.context.ts here. And I'll go ahead and export a const here called Auth Context that's going to get the request passed in. And we're going to go ahead and firstly check to see if we have the request headers.authorization on this request. And if we do, we're going to go ahead and return a sample user. So you could imagine if we have this authorization token at GWT, we'd go ahead and validate the GWT here, pull back the associated user, and return it so that we have it available in our GraphQL microservices. For now, we'll go ahead and assume if it's applied, it's valid, and return a dummy user here. So we'll provide a user object with an ID of 123. If no authorization header was provided, we'll throw an unauthorized exception here. So now to hook this up into our gateway, we'll go into our app.module, and in the server object here, we can supply a new context property and pass in the auth context. So now back in GraphQL Playground, if we try to execute a post query, we can see we get a context creation failed unauthorized response back here. Because we're not supplying an authorization header, let's go ahead and try doing that now. In the bottom here, I'll supply an HTTP header and I'll have a sample authorization header here. And if we send this off now, we can see our request is succeeding. So you can see how we could implement authorization at a global gateway layer and not have to keep doing it for each of our GraphQL microservices here. Finally, what I'd like to do is actually make this user available to all of our subsequent GraphQL services when we call them in our subgraph. So we're going to go ahead and specify a new build service property here, which is going to be a function that takes in the URL that we're trying to call, and then we return a new remote GraphQL data source here from Apollo/gateway. In here, we'll go ahead and supply the original URL that we're calling as part of this options object. And then importantly, we're going to have a will send request function that takes in the request object as well as the context object that we created or exposed in our auth context. In this case, we know where we returned the user as part of the context. So we want to take that context, stringify the user, and send it as a header to our downstream service. So we can do just that now by calling request.http.headers.set, and we will set a new user header here. And for the property or value, we will call context.user, which is the path we supplied on our object here. If that exists, we'll go ahead and json.stringify the context.user. Otherwise, we'll pass in null here. So now let's go test this functionality out by going into our posts service. We want to get access to the user when we are finding all posts. To do this, let's go ahead and create a new param decorator called current user.decorator. We'll go ahead and export this current user decorator, which is a create param decorator from Nest Common. Inside here, we're going to get access to a new function where we have a data object of type any, and importantly, the execution context, which we'll call GraphQL execution context from Nestjs GraphQL. So let's go ahead and open a try catch block now, where we will catch an error. If we receive an error during our user parsing process, we'll return null to specify there's no user. Otherwise, we're going to go ahead and declare a new headers variable here where we call context.getArgs, and we're going to pull off the second argument here and call .request.headers to pull off the headers for this request. Then we'll check to see if there's a headers.user, and if there is, we'll return json.parse headers.user so that we're actually returning the user that we stringified in our gateway here. Let's test this out back in our post resolver. We'll go ahead and use the newly created current user decorator here where we get access to the user. Go ahead and now log this user out to see if we have access to it. Back in the playground, we'll go ahead and query for all of the posts. And now if we go ahead and look in the terminal for our post service, you can see we're console logging out the user object that we set in our gateway. So you can see how we can set and pass context data to our underlying services, which can be super helpful. I hope you enjoyed this video, and I'll see you in the next one. Thanks.